Welcome to EEE111 Electrotechnology. EEE111 Course Description. The course deals with basic understanding of instruments and measurements, electronic parts, generations of electricity and distributing circuits, consumer circuits, conductors and cables, wiring systems, wiring accessories, earthing and testing. Besides that, the syllabus also contains the technique of making a printed circuit board, which known as PCB, including the understanding of schematic diagram, components layout, and PCB artwork. Course outcome EEE111. At the end of the course, students should be able to achieve 4 course outcomes. First, display good practical skills in conducting experiments and projects using equipment, trainer board, suitable software, and hardware tools during lab sessions. Second, discuss the impact on society and the environment in finding the solution of well-defined engineering problems. Third, work effectively as an individual and a team member while conducting the experiments in a group. Fourth, present verbal and written communication skills in reporting the conducted experiments and projects. There are 4 program outcomes for EEE111. PO4, conduct investigations of well-defined problems, locate and search relevant codes and catalogs, conduct standard tests and measurements. PO6, consider sustainable development impacts to society, the economy, sustainability, health and safety, legal frameworks, and the environment in solving well-defined engineering problems. PO8, function effectively as an individual and as a member in diverse and inclusive teams in multidisciplinary, face-to-face, remote and distributed settings. PO9, communicate effectively and inclusively on well-defined engineering activities with the engineering community and with society at large by being able to comprehend the work of others, document their own work, and give and receive clear instructions. Syllabus content of EEE111 consists of 10 modules. The first module is general safety, symbols, schematic diagrams, pictorial diagrams, datasheets, tools and types of equipment. Second module, introduction to resistor color code, basic instrument and circuit connection. Third is introduction to electronic components and devices. Fourth module, introduction to Ohm's law, Kirchhoff's law and circuit connection. Fifth, introduction to AC circuit analysis. Sixth, introduction to wiring installation system. Seventh, installation method, conduit for a lighting and socket outlet circuit. Eighth module, direct online starter. Ninth module, introduction to simulation software. And the last module is introduction to printed circuit board, which is PCB, fabrication and components assembly. Module 1 is about general safety, symbols, schematic diagrams, pictorial diagrams, datasheets, tools, and types of equipment. The equipments for Module 1 are oscilloscope, multimeter, function generator, and power supply. Overview. For this module, students will be exposed to the laboratory's environment, equipments, and safety precautions in the lab. There are 4 contents in Module 1, which consists of Part A, Part B, Part C, and Part D. Part A is about safety rules. Part B, basic test instruments. Part C, introduction to electrical symbols, schematic diagrams, and pictorial diagrams. And Part D is about basic hand tools. Part A will be discussing about safety rules. Listing here are 5 safety rules. Number 1, students should come to laboratory session on time with proper dress, lab coat and shoes. No slippers are allowed. Number 2, students are not allowed to enter the lab without permission from the lecturer or technician. Working alone without supervised in the lab are forbidden. Number 3, do not wear jewelries. Number 4, read the instruction carefully and follow the lab procedures. Do not touch anything which you are not completely familiar. Number 5, never eat, never drink, never smoke while working in the lab. Never run the experiments with wet hands or wet body. Part B, basic test instruments. The first instrument is oscilloscope. The oscilloscope provides a two-dimensional visual display of a signal. Most commonly, it is used to show signal amplitude versus time, thus displaying the waveform of the signal being monitored. The second instrument is multimeter. A multimeter is an electrical instrument capable of measuring voltage, current, and resistance. Digital multimeters have numerical displays like digital clocks for indicating the quantity of voltage, current, or resistance. The third instrument is function generator. The equipment provides one or more waveforms at various frequencies. Typical waveforms are sine wave, triangle wave, square wave, and narrow rectangular pulse. And the last instrument is power supply. The basic purpose of a power supply is to provide a fixed voltage to the working circuit with sufficient current handling capacity to maintain the operating conditions of the circuit. Part C will be discussing about electrical symbols. Listing here are 10 common electrical symbols in electrical engineering, such as battery, transformer, capacitor, resistor, diode, DC supply, AC supply, inductor, earth ground, and photodiode. Part C. Schematic diagram. There are few tips to get the best results in drawing circuit diagrams. The first tip, use the correct symbol for each component. Second, draw connecting wires as straight lines. Third, put a blob at each junction between wires. The fourth tip, label components such as resistors and capacitors with their values. It is best to give all parts a label such as R7 and IC3. The positive supply should be at the top and negative supply should be at the bottom. The sketching shows a comparison between a good and bad schematic diagram. Part C. Pictorial diagram. The second type of electronic schematic diagram is the pictorial layout diagram. The drawing shows the actual layout of the components on the circuit board. This provides a two-dimensional drawing, usually looking down from the top, detailing the components in their exact location. On the left side, showing pictorial diagram. On the right side, showing schematic diagram of the same circuit. Now we come to the last part, which is part D, basic hand tools. Showing here are 8 common basic hand tools in electrical engineering lab, such as cutting pliers, screwdriver, desoldering gun, soldering iron, long nose pliers, wire stripper, desoldering blade, and soldering wire. With that, thank you guys for watching. Have a good day.